Okay, so in this video I am going to continue the transportation problem, which already have discussed in two different parts, part 1 and part 2. So here I am going to take the examples, same examples, and going to apply the stepping stone method to get the solutions over the least cost cell method. So already have got the results of least cost cell method. So you just go to see part 1 and part 2, there you will find this already available, this solution of initial basic feasible solution. So now I am going to apply to get the optimal solution through the stepping stone method. So now it is very simple to go same procedure, just you need to put the dot over unallocated cell, and you need to move like either horizontal or vertical with allocated cell. So in this way just you need to put positive, negative, positive, negative. So why we are going to take plus minus, already have discussed in previous video, so you can see there. So plus minus, it means just we need to check either it is going to give you some, because the quantities is, if this quantities is going to reduce, means plus and minus already have checked. If the cost is going to get reduced, it means now the transportation cost, means here the per unit cost already have given in every cell. If this cost is going to reduce in the sense if we are going to get the negative result, it means the cost will get reduced. So we will proceed with some certain steps. So now we'll see either it is going to get the negative values or positive value. Now going to proceed here. So 10 for which cell we are going to consider this cell. So 1 3. So I am going to consider this 1 3 first row third column. So now 10 is a positive value, then 13 negative value, then 9 with positive, then 8 with negative. Let's check. So 10 plus 9 19 and 13 plus 8 21, that is minus 2. Okay, so now here we have got negative value. It means here itself I have indicated now this cost is going to get reduced, means cell will get changed. Which cell is going to change, means which allocated cell is going to become the unallocated cell, and which unallocated cell is going to become the allocated. Because we have started from here and we got the negative sign, it means this cell is going to be allocated. So which cell is going to become the unallocated cell. So what is the procedure here? Procedure is very simple. Just we need to put theta. Just we need to put theta. So where we need to put theta? Where we have considered? Here we have considered. I started from here. So here just we need to consider theta. And with the negative sign we need to put here negative theta. With positive sign we need to put here positive theta. With negative we need to put here negative theta. So now theta have got their position. Now then again first giving the values of the theta, which cell is going to leave their positions and which cell is going to enter into the position into the cell. So now theta, because this one have considered theta, this one is going to enter. So which one is going to leave? Just we are going to concentrate over the negative theta. So where is the negative theta? Here 20 minus theta and 15 minus theta. Out of these two we need to find which theta is going to give you, means least positive value is going to leave the cell. So least positive value is going to leave the cell. If you are going to reduce 15, means 15 minus 15, so this will become 0. So this cell will get this cell will leave its position, and here in the theta will consider as a allocated cell. So now theta 15, if you are going to consider 15 minus 15 0, so theta values is 15. So this cell is going to leave their positions, and now 30 plus what value have considered? Theta 15. So 30 plus 15 45. So now this cell will be 45, and 20 minus 15, this one will be 5. So now here I have got 5. So now all these values have got change and cell allocations have got change. So now these cells have become the allocated cell and these cells have now become the unallocated cell. So now theta have become 15. So now 15, this is the allocated cell. Now we'll check here. If this is the allocated cell, it means what's the result is going to get by this cell. So we can check here what's the result is going to get. So now very simple to find the optimal solution. So we cannot ensure these cells already have allocated, and this result will be the optimal result. So just we'll check either this is the optimal result or some other cell is going to give you optimal result. So just we'll proceed like this. So we'll find 20 into 6, similar procedure, 15 into 10 plus 45 into 9 plus 5 into 13 plus 10 into 16 plus 30 into 5. So we'll see what is the result. So 6 into 21, 20 plus 150 plus 45 into 9, 405, 65 plus 160 plus 150. Just add all this value. 0 0 5 5 10 0 1 6 6 12 18 18 23 25 5 then 2 3 4 4 8 9 10 1 0 5 0 1 0 5 0. So now we got this result. So this result is optimal or not? So maybe this might be the optimal, or this may not be the optimal. So we'll see, because by applying Vogel's approximation method, we already have seen for the same questions optimal solution was 1020. It means this solution is not optimal, but we cannot ensure, because we are not going to apply both the method parallel. That is the separate method, this is the separate method. So now we have to proceed one by one, because we need to check all the unallocated cell. In some cells may get reduced this result. So now the solution is 1050. So we'll check either this result is going to reduce or not. If it is going to reduce, it means this is not optimal solution. So we'll move further to check. So 13 already have checked, and this cell already have got the allocated position. So now I'm going to put the cell here and we'll check. So here we need to move like previous one with all allocated cell. So plus minus plus minus. So just check which cell first 4. So 1 4 I'm going to check. 9 minus 5 plus 16 minus 10. What is the result? 16 plus 9 25 15 positive. This cell is not going to give any changes. It means here there is no changes, because result is positive. It means we need to move to some unallocated cell to check, because we have to check for all allocated cell and for all non-allocated cell. So this is the another non-allocated cell. So we can move like this, here to here, here to here, plus minus plus minus. So here plus minus means just we need to check which cell, second row second column, second row second column. So 12 minus 13, 12 minus 13 plus 10 minus 6. What is the result? 12 plus 10, 24, 22, 22 and 19. So it is positive. So no, this cell is not going to give you some reductions. So here we are not going to get some values will get reduced. So here this cell is not going to give you reduced value. So now we will move to this cell and we'll see how can we move to get a cycle. Very simple. To get a cycle, we can move, we can start from here to here, we can move up to here, we can go from here to here, then not here directly. So we can go from this cell. We have to start from this cell. So we can move up to this cell, up to here, then we can move up to here, then we can move up to here, then we can move up to here. It's a simple. I got confused. I don't know. Plus minus like this. So just to check for which cell we are going to check 3 1. So 3 1 means 14 minus 16, 14 minus 16 plus 13 minus 9. What is the result? So this is also positive. This is also positive. 14 plus 13, 27, 16 plus 9, 25. So positive. Now this cell is also going to be positive. It means we cannot go to this particular cell. So we can move to this cell, because this is also unallocated cell. This is the last cell. So here we can check if it is not going to change, it means this solution itself is an optimal solution. If it is going to change, it means here we'll get this cell will change to allocated cell, and some another cell is going to become the unallocated cell. So now here we are going to check here. So can move like this, this. So plus, minus, plus, minus. So just check here for which cell? Third row, second column. 9 minus 16, 9 minus 16 plus 10 minus 6. What is the result? 10 plus 9, 19, and 16 plus 6, 22. Okay, negative. So here we have got negative. It means this cell is going to give some, this cell is going to become an allocated cell, and some other cell is going to leave their allocation. So here going to consider theta. So now going to consider here theta now. So if this will be the theta, it means this value will be 10 minus theta. This one will be 15 plus theta. This one will be 20 minus theta. So out of all these theta, we can check which theta is going to give you the negative one. 10 minus theta, 20 minus theta. These two are negative. So here we can say, if we are going to consider theta as a 10, so this cell is going to become the unallocated cell. So this will 0, and this will become the 10, and this will 10 will reduce. So 20 minus 10, 10, and here we'll add. So 15 plus 10, 25, and then check 25 plus 10, 35, 45 plus 5, 50, 10 plus 30, 40. Here also check 45, 20, 25 plus 30. It's okay. So now these cells have got the allocation. So this new allocated cell. So now here I am going to check either the result is going to reduce. If the result is going to reduce, means the cost, the transportation cost is going to reduce, and that will be the optimal solution, because already have checked all these cells. This is the last cell, and these cells also have got allocated. So now going to check. So 10 into 16, 10 into 6, so 10 into 6, 25 into 10 plus 45 into 9 plus 5 into 13 plus 10 into 9 plus 30 into 5. So we'll see what is the result. 60 plus 250 plus 405 plus 65 plus 90 plus 150. We'll see what is the result. So now here we need to add. So 0, 0, 5, 5, 10, 0, 1, 1, 7, 7, 7, 12, 12, 12, 12, 12, 18, 18, 18, 27, 1, 6, 7, 7 plus 5, 12, 12, 12, 12, 12 plus 6, 18, 18, 9, 27, 27 plus 5, 32, 2, 3, 3 plus 1, 4, 4, 4, 4, 8, 8 plus 2, 10, 1, 0, 2, 0. So initially it was 1, 0, 5, 0. So now I have cost have got reduced 1, 0, 2, 0. So this 1, 0, 2, 0, it means this is the optimal result, because initially it was 1, 0, 5, 0 when we change the allocations, and this allocated positions is going to give the results by 1, 0, 2, 0, and we already have seen through the Vogel's approximation method also have got the same result, and once we applied the stepping stone method over the Vogel's approximation method, we got the same result. It means 1, 0, 2, 0 is an optimal solution. So we can say optimal solution is a 1, 0, 2, 0. So optimal solution by applying a stepping stone method, that is the result 1, 0, 2, 0. So very basic ideas, very basic concept, just you need to apply to solve. So this is the steps you need to apply to solve the transportation problem by applying a stepping stone method. So I already have given two examples. One examples over the Vogel's approximation method in part 2, and one examples I've given over the least square cell method in this part. So just go through with these two parts. You will get the result and try to solve some numbers of questions, and you will get the result. So once you will go for some certain numbers of questions to solve by applying the different method, first you just go for the northwest corner cell method and take that particular solutions, initial basic feasible solutions, to proceed with a stepping stone method. So you will be confident over the concept, and you will be able to solve any types of questions by applying the some different types of initial basic feasible solution approach and then a stepping stone method. So